Hi Year 12, this lesson is on 24D.1, which is about quantiles, or another name for it is K values. And the best way to understand this is probably starting with a scenario. So let's consider a population of crabs where the length of a shell is X millimeters, and it's normally distributed with a mean of 70 millimeters and a standard deviation of 10 millimeters. A biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. So anything, less than that is not allowed to be harvested. He therefore asks the question, 95% of the crabs have lengths less than what? So he wants to set like a length as a limit so that people don't harvest them, but he's got to figure that out. He or she has to figure that out. So to answer this question, this is what we've got to do. We've got to recognize that we've got to find some value of K such that the probability of X is less than or equal to K is equal to 0.95. Okay, so we're trying to find like the probability under your normal distribution curve to equal 0.95. We want to know where that line is. So we would want to know where that boundary is. So K is called a quantile. In our case, it is the 95% quantile. Okay. You need to use a normal inverse function on your calculator. Sorry, I think I just said that backwards. An inverse normal function. And because we're kind of doing backwards of what we did before, this time we're given the probability and we've got to work out what this, like the number actually is, like the score per se. I can help you and show you in class, but I've also placed a video here for you, so please watch it. It's actually super easy and really straightforward on how to use it on your TI Inspire. Let's go ahead and have a go at this example. It says if X is normally distributed with a mean of 23.6, highlight your important information, standard deviation is 3.1, find K for which the probability of X is less than K is equal to 0.95. So here we want the probability of X is less than K is equal to 0.95. What that means is you should always draw a little sketch to help you actually visualize what's happening. So if I have a normal distribution, okay, it's telling me the mean, or the mean, or symbol mu, is 23.6. Standard deviation is 3.1. Okay, so sigma is 3.1. But it's saying what value of K along here is going to give me equal to 0.95. So that's a fair way along. So it could be like somewhere over here, right? And then this is this bit, the area under the curve there, that's got to be 0.95 or 95%. Does that make sense? Okay, so I want to find, well, what's this value here? What's that K? That's what we're trying to find. Okay, so working backwards from before. So if you've just got to follow the instructions in the YouTube video, put it in your calculator, and we literally just get a value for K. So it is approximately 28.7. Okay, remember 3 sig figs, and then let me know if you can't get it. Let's do the next example. If Z is the standard normal distribution, find K such that PZ is greater than K is equal to 0.73, and interpret your result. So let's do a little quick sketch again. Okay, there's my normal distribution. My mean is, forgot to take note of this bit because it's Z instead of X this time. This is the standard normal distribution, so that means your mean is 0 and means your standard deviation is 1. Okay, sigma equals 1. So 0.73 is going to be something like, let's have a look, so it might be somewhere here somewhere. okay? Because we want it to be bigger than 0.73, so we want it on this end, right? This is greater than 0.73 or 73% of your population or whatever it is that you're talking about, okay? Whereas with the other one, we wanted, remember, up here, we looked for 95% because this 5% over here was the top 5% that the scientist or biologist wanted people to be able to harvest with the crabs and not take the ones that were smaller, right? Okay, so that's why we chose that side, whereas this one we need to choose this side. And then just put it in your calculator. So we could say the probability of Z greater than K is equal to 0.73. What you could do though is also see that that means, I think it might be easier typing the calculator this way. So it's going to be less than or equal to 0.27. And so when you put that in the calculator, we should get approximately minus 0.613. Okay, so it says interpret your result. Or what that means is that 73% of your Z distribution values are greater than negative 0.613. So that's your K here. Okay, I'll just write that in for you. This means 73% of the Z distribution values are more than minus 0.613. Okay, one more example. Let's do this one. The university professor determines that no more than 80% of this year's history candidates should pass the final examination. The examination results were approximately normally distributed with mean 62 and the standard deviation of 13. Find the lowest score necessary to pass the examination. So you've got, let's let X, actually let's just write it with the symbols, it'll be quicker. X is normally distributed about a mean of 62 and the standard deviation is 13. Okay, and so the situation we've got here is, do your little sketch, okay, there's the mean is 62, and what else does it say? No, he wants no more than 80% of the year to pass. So that means, so that's like sort of the 20% mark, so that up here, this is 80% of the people passing. Oops, I forgot my percent symbol, I think. So let me change that where I've written it. Let's put it here. This is 20% and this is your 80%. So we need to find, well, what's this pass mark here? What did he or she consider as the pass mark? And only the people above there in the shaded bit in orange are the people that have passed. So what we want is the probability of X greater than or equal to K, to equal 0.8. So really what we also want is therefore the probability of X is less than K to be 0.2. And when we put that in the calculator, we should get 51.059. So therefore, the minimum pass mark was about 52%, right? Because you can't, if you got 51, that wasn't enough to pass. Had to be over 51.0, at least 51.059. So really, 52% makes more sense. And the exercise you should do is 24D.1. Please have a go of that. Let me just write it down for you. and it is on page 644 in your textbook, Year 12.